So hello everyone again. This is lecture 7 part 1 of wave optics. In the last lecture we were discussing about the single slit experiment in the diffraction concept. We will move on with that concept only, as in what is happening in the single slit and what is happening in double slit. Is it a combination of interference which is happening, or it is something different? Let's move on to that discussion now. So I am Sameer Lavankar. Let's begin our discussion. So first of all, let us go on to the course outline here. So the first of all, we started with the introduction concept, that is about what is wave theory, how it is different from the Descartes theory of light. What was Descartes theory? It was a particle theory of light which predicted that the light is always consisting of different particles and it moves in a straight line. So after this we understood the concept of Huygens principle, in which we defined a new concept called as wavefront. In the wavefront concept, first next thing was, if we know the value of wavefront at if we know the shape of wavefront at some time t is equal to 0, then we can find out the wavefront at some time t is equal to tau. Using the same concept of Huygens principle and wavefront, we found out the value of refraction and we proved the refraction and the reflection laws in the third concept. Then after this we went to coherent and incoherent addition of waves, which was nothing but, coherent is nothing but the waves when it has a addition intensity of maximum, and incoherent is when it has intensity of 0. After this, a small concept of Doppler effect was also being understood in this concept only, and finally in the previous few lectures we moved on with interference of light waves and Young's experiment, in which we understood the Young's experiment with a single slit, then a double slit, why it is important that the double slit should be preceded by a single slit so that the phases are being logged, why it is there a need to log the phases, and all was understood in this concept. Finally, in this concept we also studied that what will be the change in the screen's interference fringes if there is, let's say, change in the source, if there is a change in the monochromatic source, if it is changed to white source of light, if the value of capital D is changed, if the value of small d is changed, etc. So this was the complete concept. Now we are in the sixth concept, that is diffraction. So what is diffraction? In the last lecture only we understood the diffraction. Diffraction is nothing but the bending of light due to any obstacle which is of the order which is same as the wavelength of light. Why it doesn't happen in our similar scenarios? Because every time, let's say if I take this case, the light cannot bend through it. Why? Because the value of the obstacle is very large as compared to wavelength. Wavelength is in the order of nanometers, and this is in maybe centimeters or meters. That's why. So now let's move on to our discussion of diffraction only. So just to reiterate to you, these were the concepts, this was the explanation, this was a figure in which we were calculating why is there a intensity as the path difference changes either in this direction or in this direction, the intensity keeps on decreasing. As you can see, the intensity is maximum here and then it keeps on decreasing as we go further away. Also then quite evident that the central fringe will be bright. So as you can see, the central fringe is bright here, and then there is followed by a dark fringe. Here also it is a dark fringe, again a bright fringe, and then again a dark fringe. So this is the complete concept. So in the last lecture we understood why is the value of this a theta we understood, then lambda by 2 also. So how we understood that at some point p for which the path differences, for which the angular difference is theta by lambda by a, then why is the dark fringe visible there. Today we will go on with the further discussion and understand why the intensity keeps on decreasing as we move further away. So this concept is done. So the last concluding point of this concept was that the contributions from the two halves of the slit, that is Lm and Mn. So this is Lm and this is Mn, therefore cancel out each other. Why do they cancel out each other? Because if we take any 2 points, one in Lm known as M1 and in Mn known as M2, we can find every point M2 such that M1 M2 is equal to a by 2, and because a by 2 is a difference, part difference is known as lambda by 2, and we know for destructive interference, if part difference is lambda by 2, destructive interference occurs and hence the intensity is 0 there. Therefore, what we got is at some point p for which the angular difference is lambda by a, then always there is no fringe observed, that is dark fringe is observed. Okay. So now let's move on to today's discussion now. So let me start from here only. So theta approximately equal to lambda by a gives the angle at which the intensity falls to 0. Quite evident, this was the concluding point of the last lecture. Now one can similarly show that the intensity is 0 for theta is equal to n lambda by. Quite evident, as we know that for destructive interference to occur, the path difference should be a multiple of lambda by 2. So n lambda by 2, so lambda by 2, 2 lambda by 2, 3 lambda by 2. For every value of n lambda by 2, the destructive interference would occur. Therefore, on the similar instances we can say that the intensity is 0 for all theta is equal to n lambda by. N can take any value between 1 to infinity. So, where n being any integer except 0, quite evident, because at n equal to 0 a central bright fringe is observed here. Therefore, for n equal to 0 this case is not valid. Okay, so this point is also explained. This is again the concluding point on the last lecture only. Now notice that the angular size of the central maximum increases when the slit width A decreases. So quite evident. So as you can see that for A, if we decrease the value of A, if the A value is decreased, then the angular size, what does it mean by angular size here? Angular size means let us say I write this only as angular size, or as it is written here. So this is that angular size being talked about here. So it is saying that the angular size of the central maximum as in when this value is being talked about at this position here, then it increases when the slit width A decreases. So quite evident, this is the complete case. Now it is also easy to see why there are maxima at theta is equal to n plus 1 by 2 into lambda by A. So now this is the case, we need to understand that why, as the path difference goes on increasing, there is a decrease in the intensity. So, and why do they go on becoming weaker and weaker with increasing n. So in the next slide let us move on to this concept only. So please look over here carefully, very interesting concept. So for now, for example, we are taking an example of theta is equal to 3 lambda by 2a. So theta is equal to 3 by 2 into lambda by A, okay, which is midway between the two of the dark fringes, which is midway between two of the dark fringes. Quite evident, as this is a dark fringe here, as this is a dark fringe here, so it is between two of the dark fringes. So divide the slit into 3 equal parts. So now for this case what we are doing is, we had this slit, let me denote this here. So let us say this is the slit being talked about. So let us say this is L value, this is our N value, and now we are dividing it into 3 parts. So 3 parts can be divided like this. So these are the 3 parts of the slit. So this is the first part here, this is the second part here, and let us say this is the third part here. So divide the slit into 3 equal parts. Now if we take the first 2/3 of the slit, so now let me change the color. Now if we are only and only capturing this portion here, let us say we are only and only capturing this portion for now. So what will happen, if we take the first 2/3 of the slit, the path difference between the two ends would be, so as quite evident in the previous concept we understood that if we know the if the slit width being talked about is known as y. So let us say, okay, if I tell it like this only, if the slit width is y and the angular reaction which it makes, sorry not reaction, angular angle which it makes at that point P is theta, then that point, then the path difference is nothing but y multiplied by theta. So on similar scenarios, if we know the value of path difference, slit difference here, so what will be slit difference here? It will be nothing but, it is as the A divided into 3 parts, it will be A by 3, A by 3, A by 3, so it is A by 3, A by 3, A by 3, hence this region would be 2 by 2 A by 3. Hence the path difference will be nothing but 2 A by 3 multiplied by theta. So just writing that concept here, so that will be nothing but 2 A by 3 multiplied by theta. Now from this equation we can find out the value, we can just substitute the value of theta, hence let me write the path difference like this. So path difference is equal to 2 A by 3 multiplied by 3 by 2 multiplied by lambda by A. So here quite evident, 2 gets cancelled, 3 gets cancelled, A gets cancelled, hence we found the value of path difference equal to lambda. So this is the same thing being talked about here, that the path difference which we got from these two scenarios is lambda. That means for the slit difference of 2A by 3 we are getting a path difference of lambda. So if we divide that slit into 2 equal parts, then it is the same scenario which we learned in the previous concept, for which if we have a point M1, let us say, let me denote it more clearly. Now let us say I write this point as M and this point as O. Let us say I denote a point here at M1 and I denote one point here as M2. So for every M2 we will find a point in M1 such that the path difference observed by these 2 points is always lambda by 2. It is the same case as previous scenario. Therefore what happens is, so just let me keep on iterating from here only. So the first 2/3 of the slit can therefore be divided into 2 halves. So this is the slit being talked about here. Let us say we are just denoting on the 2/3 part. be divided into two halves which have a lambda by 2 part difference. Quite evident, if the part difference of complete is lambda, then for half scenario it will be lambda by 2, which can be calculated. It is a similar concept which we talked about when we are talking about the dark fringes concept. So therefore the first 2/3 of the slit can therefore be divided into two equal halves which have lambda by 2 part difference. Therefore the contributions of these halves cancel in the same manner as described earlier. Therefore there is no influence, if I try by telling you, so there is no influence of these 2/3 part. The only influence, the only intensity which we get at any point apart from the central fringe after any dark fringe is only and due to the part which is remaining in this portion here. Always it is only due to this part which is remaining here. Every two divisions get cancelled each other. Why does it cancel each other? Because the value of path difference for any point m1 in, let's say, first division has a point m2 such that the path difference is lambda by 2, and we know that destructive interference to occur, the path difference should be equal to lambda by 2, and hence it will change to a dark fringe. So therefore this is the complete concept of why the intensity keeps on decreasing as we move on. Okay, so this was just a simple case of 3 lambda by 2a. Now what will happen if we keep on increasing? So next will be nothing but 5 lambda by 2a, 7 lambda by 2a, and etc. So let me take the scenario of 7 lambda by 2a or 5 lambda by 2a if I can. So let us suppose 1, 2, 3, 4. So 1, 2, 3, 4, 5. So let us suppose that this is the first division here, and say, let's say this is, so this, let's say this is the point L I am talking about, let's say this is the point M I am talking about. So here let's say this is the first division, second division, third division, fourth division, and fifth division. So now what will occur in this scenario if we again take the similar cases? Then here this has a part difference of again lambda, and similarly this has a part difference of again lambda. Therefore what will happen? Lambda by 2, lambda 2 for half of them will get cancel each other, and therefore there is no significance, or due to this slits everything gets cancelled. Therefore only and only which is taking part in bringing a bright fringe is due to this part, so that is divided into 1/5 part. So first of all, in the for the central, if I just keep on writing it as a table, so for central fringe what was happening is the intensity was happening due to the complete width A. So width available for bright fringe, if I write like this. So for central fringe the value of the complete width was available. If you are finding out for 3 lambda by 2, this is nothing but the value of theta. So value of theta will be 0 in the first case, and this is again then for next scenario it will be 3 lambda by 2a. So what will happen in this case? The value of width available for bright fringe is nothing but a by 3. Similarly for 5 lambda by 2a it will be nothing but a by 5. For 7 lambda by 2a it will be a by 7. So as you can see, quite evident that the value of the width available for bright fringe keeps on decreasing, and because the slit width is decreased, therefore the intensity also gets decreased. Hence we can see that as we move on either in this direction or in this direction, because theta can be either above or below, it does not matter, the intensity keeps on decreasing. So this was the complete concept of single slit. We understood first of all why it cancels each other and therefore why dark fringes occur, and similarly we understood why the intensity keeps on decreasing as the part difference is increased. Okay, so this concept is also increased. So let me just write here like this, that it decreases. Okay. So only the remaining 1/3 of the slit contributes to the intensity at a point between the two minima. Quite evident. So this is the portion of two minima here. These are the two minimas, and between these portion is the bright intensity fringe which is occurring. Clearly this will be much weaker than the central maximum, quite evident, because in the first case full width A is occurring, and in another case just after it only A by 3 is occurring. Therefore the intensity is much lower in this case. So clearly this will be much weaker than the central maximum where the entire slit contributes in phase. So this is the simple explanation which I just told you. One can similarly show that there are maxima at n plus 1 by 2 lambda by with n is equal to 2, 3, etc. So for n is equal to 2, we will get 5 lambda by 2a, 5 lambda by 2a, and similarly for n is equal to 3, we will get 7 lambda by 2a, and so on. These become weaker with increasing n, since only 1/5, so 1/5 is here, then 1/7, so 1/7 is here, etc. of the slit contributes in these cases. So quite evident, I explained to you why this is happening. The photograph and the intensity pattern corresponding to it is shown in the above figure. So, this is the figure being talked about here, that is, this is the figure in which the intensity keeps on decreasing as we move, as the part difference is increased. So, this was the complete concept of single slit. Now, let us move to double slit. So, what is the double slit concept, what is it happening? Just look on, and this is nothing but we are just pondering over this question that whenever we find out. So, in the previous scenario what we did was we used a single slit. So, let me just explain you. So, let me explain you that it was a single slit here. Now, we are talking about, let us say in the similar case we have a double slit. So, what does it happen in double slit? Is it an interference of two diffraction things or a different phenomena occurs? So, we are just trying to answer this question in this concept. So, let us move on. So, what does it say? Let me iterate to you. So, in the double slit experiment we must note that the pattern on the screen is actually a superposition. Please look over this line very carefully. So, in the double slit experiment we must note that the pattern on the screen is actually a superposition of the single slit diffraction. So, it is nothing but a single slit diffraction plus single slit diffraction. So, the complete component of what is even effect which a single slit happens twice is being superimposed on each other, and hence we get a pattern which is an interference pattern known as like this from each slit or hole, and the double slit interference pattern. Double slit interference is just a pattern of superposition of two different single slit diffraction patterns. So, it shows a broader diffraction peak in which there appear several fringes of smaller width due to double slit experiment. So, what does it try to say is how does this superposition happens is as quite evident from this figure. So, please look over this interference pattern here. So, this is the intensity being shown, it is maximum here and then it keeps on decreasing. If we just rotate this and put in this figure, then we can see that what happens is this is the figure, this is that single slit figure being talked about. So, what it is saying is if we try to superimpose two different values, the dark fringe and bright fringe are nothing but shown like this. So, it is nothing but a superposition of many central fringes being talked about here. So, it shows a broad diffraction peak in which there appear several fringes of smaller width due to double slit interference. The number of interference fringes occurring in the broad diffraction peak depends on the ratio d by a. So, here what does it happen? How many interference fringes will happen in a broad diffraction peak? So, this can be understood as a broad diffraction peak here. Depends on the ratio of d by a. D by a we know what is the value of d, what is the value of a. A is nothing but slit width, small d is the value being talked about in the previous lectures. That is the ratio of the distance between the two slits to the width of a slit. Let me write it in diagram way only so that it is much more understood clearly. So, if this is the slit being talked about here, then small d is nothing but this value, that is the distance between the two slits, and small a is nothing but this value. So, this is value of small d and small a. So, it depends on the ratio of d by a, that is the ratio of the distance between the two slits to the width of a slit in the limit of a becoming very small. So, now we are taking a case in which a is very less, a is becoming very small, the diffraction pattern will become very flat and we will observe the two slit diffraction pattern. So, in the scenario in which we are assuming that a value is very less, so it is assuming to be a pinhole, then what happens is we can see an interference pattern which is very flat, similar to this scenario here. So, this is the complete concept being talked about here, that is what we understood that double slit is nothing but a superposition of two different single slit diffraction patterns. So, now let me close the discussion here only. In the next lecture we will continue from double slit experiment and then we will go to resolution and different concepts important for diffraction. So, for now let me stop it here. Thank you.